Hello everyone, so in this video let us talk about one more problem from LEETCODE, that is from the interview preparation series I've been working on from LEETCODE itself. So the problem name is valid parenthesis, and you can check out the complete playlist in the description of this particular video. So go check it out. It has a lot of videos regarding the placement series or the interview series from LEETCODE. Okay, the problem name is valid parenthesis. So the problem statement goes like this, that you're given a string S consisting of these type of different brackets, so opening bracket, closing brackets, and like curly brackets and hard brackets, square brackets, and so on. So there are three types of brackets you are having, and the particular string is called valid if for the open brackets there always exists the same type of closing bracket, and the open bracket must be closed in the correct order as well. Okay, so you know that how the brackets open and close, so that it will be in the correct order. So you cannot tell that this is a correct order because it is opening in this order and the closing is square bracket. Similarly, this is correct because opening closing in the same type only. So these are the particular sequences of string, and you have to just tell that whether it is a valid parenthesis sequence or not. Now in this type of scenarios, like whenever I see parenthesis type problems, then I'm not saying 100%, but in most of the cases stacks can be used, because stacks can be used to open and close in a sequential manner. Okay, so what I'm trying to do here is that let's say I have a sequence like this. So opening, okay, then hard bracket, then closing, okay, hard bracket, close, and closing. Let's say that this is the sequence we have, and we have to just check that whether it is a valid sequence or not. So what I'll do is I will make a stack. Okay, so what I'll do is that, okay, I'll iterate over the string from left to right, and if I see a opening bracket, I'll push that in the opening bracket. Let's take this. So I have an opening bracket, then I again see a opening bracket, I'll push it like this. Okay, then I see a closing bracket, so I'll see a closing bracket like this, opening bracket again, then I see a closing bracket. Now this is invalid. Why? Because see, this is somewhat like this is meaning that this is closing this part, this bracket, because this should be closing this, not this. So this is an invalid sequence. So you can tell that this is an invalid sequence. That is fine. But let's say what I'll like remove some part, put it like this, then again open, close, close, close. Okay, then what you can directly see here is that, okay, whenever I see an opening bracket, I will push that into the stack. So we have going from left to right, opening, so opening, then this open hard bracket, then close. Whenever I am closing a bracket sequence, I will check that whether the top of the stack is the same opening bracket that must be closing this closing bracket. It like should be same parity. So if this is like a hard bracket closing, the top of the stack should be hard bracket open, because they will match with each other. If they match with each other, then what will happen? That they will match out. So this will match with this bracket. So I will pop out this particular bracket from the stack because that is matched. So whenever a particular sequence has got matched, we have to pop it out because that is of no use of now. They actually got matched out. So what I'll do is that I will pop out this part now, and we are on this now. So this is also completed. Now we are on this. So it is again opening. I will push that. Now it's a closing. So closing of this and this type are same. So we will pop out this particular top one. Then we are on this particular one. So this is again closing, and this type are same. So again we are like pop out the top one. And then again closing and closing. This type and this type are same. So I will again pop out. And in the end, if the stack becomes empty, which means that all the particular brackets are exactly closed in a correct sequence, so it is a valid parenthesis sequence. That's the overall logic here. So we will just use a stack in most of the cases. So I'll tell you how we are going to implement that. So what we are trying to do is that we are using a stack here of characters. We are using a for loop over this particular string that we have. If we have open bracket of any of those types, like open, like this open curly bracket, a hard bracket, we'll just push that particular character into the stack. Okay. Now let's say that we have a hard bracket closing. If we have a hard bracket closing, what we'll check that if the stack should not be empty, it should not be such that we have a hard bracket and the stack is already empty. So the stack is not empty, and the top of the stack should be an opening of hard bracket. If that is fine, we will pop the top of the bracket and we will return, like we will keep on moving ahead. Else, if the top of the bracket is not hard bracket or it is like empty, we'll just return false, that this is a not valid sequence. Similarly, then we moved on to the curly brackets of closing. We'll do the same thing. It should not be empty, and the top should be of the same parity of the opening one. Similarly, we'll go to the normal brackets, and normal brackets, it should not be empty, and like similarly, it should be the top should be an opening bracket of the same type. If all of them meet correctly fine. This for loop will not terminate at any point of time. In the end, also we have to check that the stack size should be 0 because everything should be matched with everything. If in the end the stack becomes equal to 0, then only we should return true, else we return false. Okay, so that's the overall logic and code for this problem. Okay, the time complexity for this problem is O of, so what you can see, the time complexity of this problem is O of n because we're just iterating from left to right. And the stack is also like just pushing and popping out. So we're just iterating over from left to right. So that is the overall time complexity. The space complexity, because we're using a stack, we are like pushing out the elements, popping out the elements. So it is of O of n because in the worst case, all the elements are there in the stack. So all the n elements, all the n buckets. So it can happen that we have a sequence like this only, like n sequences of all opening. So in this stack, we'll just push everything into the stack. So everything is pushed into the stack. So it is like all open. Though in the end, this is the false sequence, but still the stack is of completely filled. It is O of n. So in the worst case possible, the space complexity required for the stack is O of n, and the time complexity is also O of n. That's the overall logic and code part for this problem. Thank you for watching this video till the end. I will see you next one. Keep coding and bye.